In this video, we're going to do some more practice on integrals that lead to inverse trig functions and the derivatives of the inverse trig functions. So first one, we have integral of dx over the square root of 25 minus x squared. So if you imagine in the checklist in your mind, you try letting u be the whole 25 minus x squared, then du would need to be a negative 2x dx. But we don't have that power of x that we need, and so that means that isn't going to work. So that's really our only other good option. So now we start thinking for an inverse trig function. Since we have a square root, we think it's probably going to be either an arc sine or an arc secant. And because we have the number preceding the subtraction, we're thinking it's going to be an arc sine. So in moving to that end, we're going to try to make a 1 where we see the 25, and so we will factor that 25 out. That will leave behind a 1 minus x squared over 25. The 25 will come outside the radical as 5 and outside the integral as 1/5. That will leave us with a 1 minus x squared over 25. We're going to see the x squared over 25 as u squared. That means the u is going to be x over 5, which we are thinking of as being 1/5 x. Then its derivative will be 1/5 times dx, and that's going to make the dx be 5 du. So we get our integral now goes to 1/5. The dx is replaced by 5 du, and we get the square root of 1 minus u squared in the radical, and those 5's will cancel, so it looks like it's going to be an arc sine of u, and then we'll go back to our x's, and so our final answer is going to be that it's an arc sine of x over 5, and then our constant of integration. On the next one, we're taking the derivative, so we're going to get du over the square root of 1 minus u squared. That's what we get for the derivative of an arc sine. So the derivative of x cubed is going to be our du. There's 3x squared, and it's going to be the square root of 1 minus x to the third squared. We multiply the exponents, so that's going to be an x to the 6th. The next one, we see that, again, our thought process goes, can we let u be the entire denominator? If so, our du is going to have an 18x. We don't have the power of x in the numerator that we need, so that isn't going to work. So we look to an inverse trig integral, and because we don't have a radical, that means we're going to hopefully make this into an arctangent. And so to start with, we want to make that be a 1. So we're going to factor a 5 out of the denominator and pull that all the way outside the integral as a 1/5. That's going to make that be a 1 plus, and then that's going to be a 9/5 x squared. So we're looking at that as our u squared, so that means u is going to be 3 over the square root of 5x. Yuck. Du is going to then be 3 over the square root of 5 dx, and our dx will be the square root of 5 over 3 du. So our integral now has this 1/5 outside of it. Our dx is going to be replaced by a square root of 5 over 3 du, and we'll get our 1 plus u squared in the denominator. That will come outside, and it'll become the square root of 5 over 15, and our integral is what we want. That's going to be our arctangent, and so that will give us the square root of 5 over 15 arctangent of our u, which was that 3 over square root of 5x, and plus c, the constant of integration. On the next one, the derivative, our formula is going to be that this will be du over the absolute value of u times the square root of u squared minus 1. So our du is going to be the derivative of e to the 3x, which is going to be e to the u du. And then we're going to get an absolute value of u, which is e to the 3x. And then we'll get the square root of u squared, but e to the 3x squared, remember you're going to multiply exponents when you raise a power to a power, so that's going to become e to the 6x minus 1. Now we look at that for a moment and hopefully recognize that e to the negative 3x, an exponential, is never negative, so we don't really need those absolute value signs. So once those absolute value signs are out of the way, now we can cancel that e to the 3x with that e to the 3x, and our final answer is going to be then 3 over the square root of e to the 6x minus 1. Some pretty high-speed algebra going on there. Let's scroll up a little bit. And here, again, we imagine we're going to let u be the inside of that radical, but du is going to need a power of x, which we don't have in the numerator, and we can't put it into the denominator, even though it looks like we've got one there. That's not going to help us with the u du substitution. So since that isn't going to work, our only other good option is an inverse trig. And since we see a radical, we're thinking arc sine or arc secant, and because we have the x squared preceding the minus sign, we're thinking this is going to be an arc secant. So in order to make that an arc secant, we're going to factor a 9 out of the radical to make that be a 1. So the 9 is going to come out of the radical as 3, and all the way outside the integral as 1/3, since it's in the denominator. We're going to still have that x outside for now, and when we divide through by that 9, that's going to be 4/9 x squared minus 1. Now we can see that this is going to be our u squared, which means u will be 2/3 x, du will be 2/3 dx, and our dx will then be 3/2 du. So our evolving integral here, now the dx will be replaced by 3/2 du, and that's going to now be an x outside the radical, and inside is a u squared minus 1. So we can bring this 3/2 outside. It's going to cancel with the 1/3 and be a 1/2, but we have another issue here. We've got this x that won't mix in with the u's, so we can't proceed with the integral until we can get this x in terms of u. So we go back to our u substitution, and we can see that x is actually going to equal 3/2 u. So we will replace the x that we have in that denominator by 3/2 u, and there's the rest of our integral. Now that 3/2, we're going to pull outside the integral, but remember that's in the denominator, so when you divide by the 3/2, that's going to become 2/3 out here. And so that we can cancel with the 2, so at long last we're back to a 1/3 times the integral of du over u times the square root of u squared minus 1. That's the integral we were trying to get to, because that's going to be an arc secant. And remember, it's going to be an arc secant of the absolute value of u. And when we plug that in, but going back to x's, that's going to be the arc secant of the absolute value of 2/3 x plus c. Try not to infringe on the space that I'm going to need on the next problem. Okay? All right, now our derivative for an arctangent is going to be du over 1 plus u squared. So the du is going to be 1/3, and the 1 plus u squared is going to be x squared over 9. Now, we don't want to leave fractions in fractions, so we would like to get rid of both of those denominators, the 3 and the 9. We can do that in one step if we multiply top and bottom by that least common denominator. So when we do that, that's going to cancel that 3 and the 1/3 and just be 3. We're going to have to distribute this 9, which will make that 1 into a 9, and which will cancel that denominator. And so our nice aesthetically pleasing derivative is going to be 3 over 9 plus x squared. Okay. Now it's time to get creative here. Again, if we try to make our u substitution, say u is 4 minus x squared, du is going to be a negative 2x dx, and we say, well, shoot, we've got that power of x that we would like, but this plus 2 is not going to work. That's not going to fit with that. So our clever solution to this is to split this into two integrals. We're going to take the x over the square root of 4 minus x squared, and for this one we've already got a good u substitution along the way here, and I'm going to change colors here. So then I'm going to go a plus, and we're going to make the 2 over its square root of 4 minus x squared as its own integral entirely. I'm going to put the dx's back in there. Okay, now the first one, the yellow one, we're well on the way here. So we can continue here and say dx is going to be du over negative 2x. This substitution is going to work in that integral. So that's going to become x over, it's going to be a square root of u, because we called the entire 4 minus x squared our u. The dx we're going to replace with a du over a negative 2x. We can cancel those x's, pull that extra negative 2 outside the integral as a negative 1/2. And in a more integral-friendly form, we're going to write 1 over square root of u as u to the negative 1/2. That's just going to be a power rule integral, so that'll give us u to the 1/2. We'll get its reciprocal, which will have to still be multiplied by the negative 1/2. So that's going to be a negative. Our u, we said, was 4 minus x squared, and then we're going to hold a minute because we got to go back and do the other half of our integral. Now, for the white integral, our 2 over the square root of 4 minus x squared, the substitution we did here is not going to work because we don't have an x there. This one is going to become an arc sine. So for this one, we're going to factor that 4 out of the denominator. It will come out as a square root of square root of 4, which is 2, which will come all the way outside the integral as 1/2. And if we want, we can bring that 2 outside as well, or I'll leave it there for a moment and cancel it. So now what we have is 1 minus, and this is going to be x squared over 4 dx. We can go ahead and cancel those since I mentioned that already. We're thinking of this as being u squared. So our u is going to be x over 2, which we'll think of as 1/2 x. That will make du be 1/2 dx and make dx 2 du. So our integral now is going to look like the 2 du in the numerator, replacing that dx, and the square root of 1 minus u squared in the denominator. That 2 can come outside, and the integral of 1 over the square root of 1 minus u squared is going to be our arc sine of u, which we're going to call to arc sine of, I guess, x over 2. So our final answer will combine that, so this will come down and join our earlier integral. So we have another 2 arc sine of x over 2, And after all this, let's not forget our constant of integration. And there we go. Now we're doing some serious calculus. Okay, now the next one, we have the derivative of an arc sine is negative du over the square root of 1 minus u squared. So the negative du is going to be just a negative 1 because the derivative of x plus 4 is just 1 plus 0. And then we're going to get the square root of 1 minus, and that's going to be an x plus 4 squared. That would probably be okay. If you want, we can distribute in that, multiply out that x plus 4 squared. So that would be x squared plus twice the product would be 8x plus 16. And that could be further simplified into the square root of, let's see, I guess we're going to get 1, and then, let's see, a negative x squared, and we'll get a minus 8x, and the negative 16 plus 1 will be a negative 15. And I don't know if that has any advantage over the earlier one, so I think either of those would be just fine. Okay. Let's see what we got on the plate here. So the next one, we see that if we try to let u be that entire x squared plus 4x plus 6, the du is going to be 2x plus 4, and we don't have any of that stuff there. So that isn't going to work. So we think, well, what inverse trig integral can we do? And because there's no radical, we're thinking this is going to be an arctangent. But remember, an arctangent needs to be something like du over 1 plus u squared. And it's not looking like what we have in the denominator. So what we're going to do is complete the square in the denominator. So we will look at the x squared plus 4x. We're going to push that plus 6 off to the side because it isn't what we want it to be. What we want is half of the middle term squared. Half of 4 is 2. 2 squared is 4. So I'm going to add in the 4, and then I'm going to turn right back around and subtract it off. So I've really just added 0, but with a purpose. So this now will become dx over, and that x squared plus 4x plus 4 will factor into x plus 2 squared. The negative 4 plus 6 is going to be a plus 2. Now we're headed towards this du over 1 plus u squared, so we need to make that 2 be a 1. So we're going to factor a 2 out of the denominator, pull it all the way outside the integral as 1/2. And now what we've got is that x plus 2 squared over 2 plus 1. This x plus 2 squared over 2 is going to be our u squared in our u substitution. So the u will be x plus 2 over the square root of 2. Now, you don't have to write it out, but we want to be able to see that as a 1 over square root of 2 times x, and then the plus 2 square root of 2 doesn't really matter. This is the part that we want to be able to see so that we can recognize that du is going to be 1 over square root of 2 dx, and so dx is going to be the square root of 2 times du. Okay, so we've got 1/2 integral. The dx is going to get replaced by the square root of 2 du. That's going to be all over now u squared plus 1. So that square root of 2 comes outside, so we're going to get square root of 2 over 2. The integral of du over u squared plus 1 is going to be arctangent of u, and so that is going to become the square root of 2 over 2 arctangent of the u we said was this crazy x plus 2 over square root of 2, and then we'll tack on our constant of integration. Okay, now we're going to do a derivative. So the derivative of arc cosine, this is going to be a bit of an adventure here, is going to be a negative du over the square root of 1 minus u squared. So the du part, the negative du, is going to be a negative. And now we're thinking of this as 9 minus x squared to the 1/2 power. So we have a chain rule derivative, 1/2 times 9 minus x squared to the negative 1/2 times the derivative of the inside function, which is going to be a negative 2x. All of that is du over, and then we've got the square root of 1 minus ru, which is the square root of 9 minus x squared, squared. Okay, now the calculus is done, but our algebra is only just beginning. We can cancel the 2's and the negatives, so those are going to disappear. We're still going to have this x, and I'm going to move that into the denominator. So that's going to be just an x left on top, and we're going to move that square root of 9 minus x squared into the denominator. Now, looking at this part down here that was already there, squaring the radical is going to remove the radical, but we're going to have to remember to distribute that that negative sign that's out in front there. So that is going to become, let's see, 1 minus 9 is going to be a negative 8, and the minus negative x squared is going to become x squared. So we're going to get that square root of 9 minus x squared times x squared minus 8. I guess you could, because they're both in radicals, multiply their insides, but I think that would just be even messier. So I think I'm going to use this opportunity to just put a box around it and call that good. Okay? Okay, one more to go here. So here again, if we try to let u be this entire denominator, then our du is going to be a 4 minus 2x, and we don't have that power of x, so that isn't going to work. So we're thinking, I guess it must be some kind of inverse trig function. Now we have a radical, so that narrows it down to an arc sine or an arc secant. Because we see a minus and then an x squared, we're thinking this is going to be an arc sine. Now, if it's going to be an arc sine, we need it to be a square root of 1 minus u squared, and so that means we're going to have to complete the square inside this radical. Okay, so I'm going to switch the order, and I'm going to factor the negative out because we want the coefficient of x squared to be a positive 1 before we complete the square. So I'm going to leave some space there. Now we're going to take half of that middle term, which is 2, squared is 4. I'm going to add that in. Now that 4 is getting multiplied by that negative, so that's really adding a negative 4 inside the radical. So I will make that be 0 by adding 4. So now our integral is looking like the square root of, and I'm going to write the positive term first, 4 minus, and then I'm going to write that in factored form, x minus 2 quantity squared. Now we're making progress towards, remember, we're trying to get the square root of 1 minus u squared. So now we're going to factor that 4 out. It'll come outside the radical as a 2 and outside the integral as a 1/2. And so now what we're looking at in that radical is going to be a 1 minus, and that's going to be x minus 2 squared over 4. This is what we're thinking of as u squared, so that means u is going to be x minus 2 over 2. Now you don't have to write this out, but at least in our mind, we're looking at that as 1/2 x, so that when we take its derivative, we'll get a 1/2 dx, and dx will be 2 du. So we've got 1/2 integral. The dx will replace by 2 du, and now our radical is a 1 minus u squared. So the 2 and the 1/2 are going to cancel, and the integral is the integral we want. Du over the square root of 1 minus u squared is going to be arc sine of u, and then we'll go back to our x's, and say that's an arc sine of x minus 2 over 2 and our plus our constant of integration c. Okay, and there's a lot to this, and it does take practice.